Okay, we're starting chapter 28 in Tech Math 4, and we're in section 1. And this has to do with series. So a series is something that's being added together. So the summation of x, and I'm going to go from 1 to infinity. And summation n. Summation n 1 to infinity. So I got 1 plus 2 plus 3 plus 4 plus 5. And that would be a series. If it's not a series, what is it? It's I don't remember. All right. So now the issue is, if I have this series that goes 1 plus 2 plus 3 plus 4, does it converge or does it diverge? So if I look at the limit as n approaches infinity of the summation of n equals 1 to, well, we'll go to a, as a goes to infinity of n equals 1 over n, yeah, something like that, then the first thing I would have is a 1 and then a 3 and then a 6 and 5. Well, this is going to be pretty big pretty quick, so that's going to be that story. But we have to figure out how these things converge. So if I look at another series, I look at summation k equals 5 to 9, and I have k minus 2. All right, well, that'd be a 3 and a 4 and a 5 and a 6 and a 7. So that's 5, 6, 7, 8, 9. And that would converge. So 10, 20. So that'd be a 20. Not that I would really care about that. So now, if we have a thing that goes n equal 1 to infinity, and I have a n. So I got a1 plus a2 plus an plus, goes on forever. The issue is, how do we know whether these guys are converging or not? Well, we have a partial sum, so the partial sum of 1 would be that. The partial sum of the first two terms, a1 plus a2. The partial sum of the first three terms, a1, a2, a3. a2, a3. And then, so we look at, if I take the limit as n goes to infinity of that partial sum, and it's equal to some value s, and it's a finite value. Finite n, phi, n, I, t, finite value. Then we say that this guy converges. But if I look at the limit as n approaches infinity of that partial sum, and it just keeps on going up, then it diverges. And we say it does not exist. So being infinite means it doesn't exist. I don't have one. All right, so that's my rules now. So now, how do I tell that? Well, if I have a series and I have the limit as n goes to infinity of an, and if that's not equal to 0, okay, so this guy's not getting smaller, then I say, well, this guy an diverges. So even if I had something that was, so if I had something that was 1 plus 1 plus 1/2 plus 1/2 plus 1 plus 1 plus 1/2 plus 1/2, that's not, my an as n goes to infinity doesn't get smaller. It's not 0. If it's not 0, then the series is going to diverge. All right, bottom of page 956. If I have something n equal 1 to infinity, 1 over n to the p. And this particular series is going to converge for p greater than 1. And it's going to diverge for p less than or equal to 1. Okay, so if this is a fractional exponent that I'm raising it to, then I'm gonna diverge. If it's a whole exponent, then it's gonna converge. So if I had 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, that'd be n is a 2, right? And so 2 is greater than 1. This guy's going to diverge. It's going to converge. And I look at that limit. If I look at the limit as n approaches infinity of 1 over n squared, I see that that's 0. So I don't get a contradiction there. We call that the p-series test. All right. And I think one more and then we're done. More than one more. Then we have a comparison test. And it says I've got summation an, summation bn, and 1 to infinity and 1 to infinity. And I know that an is less than bn at some point for all n where n is less than some capital N. So I don't necessarily have to start out that way, but sometime in the future that's the case. These guys, the ANs are always smaller than the BNs. If that's the case, if summation BN converges, so does summation AN. And if summation AN diverges, so does summation BN. So that's a comparison test. So if we have a series that we think might converge, and we can show that it's less than individual stuff in another series, so we can use that test. And the last thing we have is a limit test before we go to the next section, and then we have more rules. So we have a limit test, and so I've got summation AN, summation BN. If these series have the same order of magnitude, then both series will either diverge or converge. Okay, same order of magnitude. Same order of magnitude. What does that mean? If this guy is x to the squared and this guy is x cubed, then that's different. If AN has a lesser order of magnitude than BN, and BN is known to converge, and so does AN, and the other way around. Okay, and with that nonsense, back to problem number 1. Yeah, problem number 1. Write in expanded form summation n equal 1 to 6 for n plus 1. Alright, so I put a 1 in, I get a 5. I put a 2 in, I get a 9. I put a 3 in, I get a 13. I put a 4 in, I get a 17. I put a 5 in, 21. And I put a 6 in, 25. So that's my expanded form. Okay. All right, next problem. Number 16. Alright, so I've got 1/2, 2/3, 3/4, n plus 1 over n plus 2. And I want to write that as a summation thing. So I go summation n equal 1 to n, 1 to n of n plus 1 over n plus 2. So if I put in a 1, I would be wrong. If I put in an n, a 1, I get a 2 up there, but I don't want a 2 up there. All right. We'll go with n. N over n plus 1, and we're going to go to n plus 1. Oh, excellent. So now I go 1, and I get a 1 over 2. I put a 2, 2 over 3, 3, 3 over 3. When I get to n plus 1, I get n plus 1 over n plus 2. And then I quit there at n plus 1. Now, where is that? Okay, good enough. Number 20. Determine whether or not the summation of n minus 1 and n equal 1 to infinity of 3n plus 1 over 2n minus 1 diverges or converges. Okay, now, gut feel, what does it do? It converges, right. Why? Well, because if I look at the limit as n goes to infinity of 3n plus 1 over 2n minus 1, I end up with 2/3 to 3 halves, which is not 0, therefore it converges, implying convergence. Now, that begs the issue, can we do that particular thing? Do we know how? And so, if I take limit n goes to infinity of 3n plus 1 over 2n minus 1, and I multiply top and bottom by 1 over n. Can I do that? Yeah, I can do that. Limit n goes to infinity. I'm going to have 3 plus 1 over n over 2 minus 1 over n. As n goes to infinity, he goes to 0, he goes to 0, and I have 3 over 2. And I'm supposed to, it's not equal to 0 by my nth term test, and therefore I converge. Okay, one more problem, and then on to the next section. Okay, so looking at number 37. 37. So I have a summation n equals 1 to infinity 1 over 2 to the n plus 2n. So gut feel, diverge or converge?
Diverge.
Did I write down the wrong thing last time? Diverge. How come you didn't catch me on that? All right, back to here. You want to change your answer now? Or? Okay, so this one's going to converge. Now, how do we know that? Well, the P-series test says that 1 over 2 to the n is going to converge, because 2 is greater than 1, and 2 is my p. And then the comparison test says that 1 over 2n plus 2n is less than or equal to 1 over 2 to the n, which is less than 1 for all n. So I'm always going to be smaller than the guy that I know already converge. If I could spell converge. Therefore, I can by the comparison test, I converge. All right, enough of that. Now we're in section 28.2, and we have a ratio test. And it says, I got something, n equal 1 to infinity of an, and if I look at r being the limit as n goes to infinity of a n plus 1 over a n, then I look at that and I find that if r is less than 1, then I converge. And if r is greater than 1, I diverge. And I find that if r is equal to 1, then I fail. So the test fails and I have to do something else. Okay, so that's my ratio test. The next test I have is the integral test. And I find that if I have some series, n is equal to 1 to infinity, an, and this series can be expressed as a continuous function f of x, which it might be able to, then such that f of n is a of n. So that's being the case. I wonder if I can get that done. No, didn't move quick enough. I'm stuck behind the wires. Given that that's the case, then summation an is equal to 1 to infinity, or integral 1 to infinity of f to the x dx. If one of these guys can diverge, they both do. If one of them converges, they both do. So this guy fails the ratio test. I use the integral test to see whether or not he converges or diverges. I wouldn't do it the other way around, because I'd use the ratio test first. Okay, that ends our 2 extra things we're doing. Now we're going to look at problem number 1. So I have summation n1 to infinity n plus 1 n times 3 to the n. Gut feeling, am I converging or diverging? What do you think? You think we're converging? So the gut feel is converge. Looks like the bottom is getting smaller considerably faster than the top is. All right, so I'm going to look at my ratio test. I'm going to look at the limit as n approaches infinity of a n plus 1. So that'd be n plus 1 plus another 1 divided by n plus 1 times 3 to the n plus 1 divided by n plus 1 divided by n times 3 to the n. So that's what I'm looking at. And now I get to manipulate it. So limit n goes to infinity. I have an n plus 2. I have a 3n here, and I have a 3n plus 1 there, so I'm going to have a 3 n plus, that's a 2, n plus 1, divided by n plus 1, divided by n. Okay, I think I did that all right. Now I'm going to go in, do an invert and multiply. Limit n goes to infinity. Okay, so I've got n plus 2, 3, n plus 1 times n over n plus 1. Okay. So I've got limit n goes to infinity. N squared plus 2 divided by 3n squared plus 6n plus 3. I'm going to multiply top and bottom by 1 over n squared. Limit n goes to infinity. 1 plus 2 over n squared divided by 3 plus 6 over n plus 3 over n squared. As I go to infinity, this guy goes to 0, that guy goes to 0, this guy goes to 0, and I end up with 1 over 3. 1 over 3 is less than 1, therefore converges. R equals 1/3, which is less than 1. Therefore, it converges. Okay. Control Alt. Let's see. So number 7. Try to get to the right page. Okay, so I got summation n equal 1 to infinity, 3 to the n times 2 to the n. Okay, so gut feel, converge or diverge?
Say diverge.
Okay, that's very good. I'll go with converge. So this guy on the top is just 3 times 3 times 3, right? But this guy's on the bottom is 2 times 2 times 2 times 1 times 2 times 3 times 4 times 5. So at some point, at times 5, the guy is going to be times 6. The guy's going to be times 10. There's going to be some point where the guy on the bottom is going to win, I think. Yeah, it has to be. Well, I don't know. But we're going to use the limit test again anyway. So I'm going to look at the limit as n goes to infinity of 3 to the n plus 1 divided by n plus 1 times 2 to the n plus 1 divided by 3 to the n divided by n times 2 to the n. Limit n goes to infinity. Okay, I'm going to invert and multiply. So I'm going to have a 3 times n divided by 2 times n plus 1. Is that what I'm going to, did I do that right? Okay, I'm going to invert and multiply 3n, 2n plus 1. And I'm going to have limit n goes to infinity, 3n over 2n plus 2 times 1 over n over 1 over n, limit n goes to infinity, 3 over 2 plus 2 over n, that guy goes to 0. This is going to be 3 over 2. So you were correct. This does diverge. Wow. Yeah, all right. This is where we get Mabel. Let's see, what are we going to do? We want the summation of I to 10. I equal 1 to 10. I equal 1 to 10 of, this is 7? 3 raised to the I divided by I times 2 raised to the I. Thank you very much. Yeah, that is bigger than 1, isn't it?
Yeah.
And if I go to 100, it's still greater than 1. And if I go to 1,000, it's still, well, I can't really tell.
It's.
Well,
I'd
but it
say
appears.
it looks like there's more lines than
But I
that.
have 1, 2, 3, 4, 5, 6, 7 lines there. And I got 1, 2, 3, 4, 5, 6, 7, 8 plus more there. So I think it's still bigger than 1. So it doesn't look like it's doing a very good job of converging. All right. So Bradley was correct. His gut feel counted. All right. And we probably could have looked at it to see if if it went to 0. We probably could have done see if that term went to 0, because it doesn't appear to be. What are we doing? That was 7, so we're doing 11 next. Okay, 11. Summation and 1 to infinity, 1 over 2n plus 1. Okay, converge or diverge? Okay, so 1 vote for converge. Bradley, converge or diverge?
Let's say converge.
Okay, 1 vote for converge. Okay, your turn. Joel, diverge or converge?
I'll go with diverge because everybody else.
Yeah, well, that was the right thing to do, probably. Yeah, because if I look at that, the P-series test is going to fail right away. And so that's probably the case. So we're going to look at R, which is going to be the limit of n goes to infinity of 1 over 2 n plus 1 divided by 1 over 2n plus 1. And I guess we had another choice that we didn't choose. I'm going to invert and multiply and come up with limit n going to infinity, and I'm going to have 2n plus 1, and I'm going to have 2n plus 3, and I see that that's going to be 1, and the test fails. So the test fails. So that means from this test, neither of you are right yet. When the test fails, we have to do the integral test. So we're going to do the integral of, is it 1 to infinity or 0 to infinity? 1 to infinity of 1 over 2n plus 1 dn. So what do I want to do? Yeah, that's good enough. We can do that. Now, we can't do that. We can't do that integral, but we can do the integral limit of b goes to infinity of the integral of 1 to b of 1 over 2n plus 1 dn. We can do that integral. And so it's improper to take an integral to infinity, but we can take the limit of something that doesn't. Okay, so that's going to be limit b goes to infinity. What is that? That's the natural log of 2n plus 1 to the 1/2, which is the square root of that, evaluated at 1 and b. And then we take the, did I skip enough steps? So I got limit b goes to infinity, natural log square root of 2b plus 1 minus the natural log of 3, square root of 3. Well, the limit as b goes to infinity of the natural log of 2b, this guy goes to infinity, therefore we're going to diverge.
So I'm good.
You good? Okay, we'll go on to the next one.
Will work.
Excellent. One more? Number 20. Okay, so that was a case where the ratio test failed. We had to do the integral test, and we got that it diverged. Number 20. Summation n equals 1 to infinity and square root of n squared plus 1. All right, so we're going to vote again. Converge, diverge, and Joel, you get to go first this time.
I'm going to go with converge.
Okay, 1 for converge. Okay,
Diverge.
1 for diverge. Eric, you're the tiebreaker.
I don't know. I'll say converge.
Converge. Okay, the instructor is going to go with diverge. All right, why is that? Well, because I have the same order on top and bottom. That's why I'm going to say that. Okay, so I'm going to look at r is equal to the limit n goes to infinity of n plus 1 over the square root of n plus 1 squared plus 1 divided by n over the square root of n squared plus 1. And then I'm going to say, oh gee, why me? Okay, I'm going to invert and multiply limit. And I'm going to have square root of n squared plus 1 times n plus 1 divided by the square root of n squared plus 2n plus 2 times n. Going to multiply top and bottom by 1 over n to the 1 over n. Top and bottom by 1 over n. Yeah, that's what we're going to do. Limit n goes to infinity. Square root of 1 plus 1 over n squared, n plus 1, over square root of 1 plus 2 over n plus 2 over n squared times n. All right, that guy goes to 0, that guy goes to 0, this guy goes to 0. And I got limit n goes to infinity, n plus 1 over n. Multiply top and bottom by 1 over n again, and I have 1. All right, so the test fails. So ratio test fails again. Isn't that convenient? So now we're looking at the integral from 1 to infinity of n over the square root of 2 of, well, we'll write it right this time, of x over the square root of x squared plus 1 dx. And we'll limit b goes to infinity. Okay, we're going to do a guess. We're going to guess that we had the square root of x squared plus 1. And then g prime would have been 1/2 the square x squared plus 1 to the minus 1/2 times 2x. And that's exactly what we have there. So this is going to be limit b goes to infinity, integral 1 to b, of, not integral 1 to b, we already took the integral, of square root of x squared plus 1 evaluated at 1 and b. Clearly undefined, and therefore diverges. And that makes us done with number 20, which we're done for the day. Okay, gentlemen, thank you very much. Unless there's some other questions we have to deal with.